Welcome, guys. Today, Gabriele is going to present GraphGym. This is the second tutorial. I would like also to say that the next talk is going to be presented by Francesco, and he's going to talk about financial time series for stock prediction. So stay tuned.
But obviously there are graph involved.
Yeah. Yeah. Okay, Gabriele.
Okay, so thank you, Antonio, for the introduction. And as I said, we are looking forward to have also Francesco joining us. So, but for today, this is the second session, and it's again about general tools that are new to PyTorch Geometric, and they are intended to facilitate experiments and to facilitate the production of experiment and experimentation with the graph neural networks. So this is the table of contents. So we will see a bit of background, and then I will present some goals and basic ideas for the usage of this tool. And then we will go through it via examples. So it's really so simple that the easiest way, in my opinion, is to check the examples. So this is also the way that is presented in the documentation, but it's really clear. So you will see that as soon as we see our example is constructed, it's very immediate to understand everything. Then I would like to point you to the details, so where you can find additional resources, but really the structure is super simple. And we'll see two examples and then discuss a bit about customization of this tool. Okay. So let's start about the background. So this tool comes from an idea outside of PyTorch Geometric, so in more general terms about graph neural network, but not restricted to PyTorch Geometric. And the initial idea was published, or the initial set of ideas have been published in this paper that you see cited here from 2020. And the idea was to define a design space for graph neural networks. So how to explore different configuration, different settings, and things like that. And the first version of this software was hosted on the Stanford Snap website under this name. You can still find it there. And also there is a GitHub page with the implementation. And the implementation deals with not only with PyTorch Geometric, also with other general tools. Okay, but now recently it has been integrated, or at least the integration within PyTorch Geometric has started. And you can find information about this coupling between the two tools in this intro page. That is the one that I used also for the preparation of this tutorial. So you can follow it, and it's really detailed introduction to all the aspects of this tool. And also there is a corresponding documentation page in the documentation. Okay. And this version is the only one that I will refer to during the tutorial. So I did not check, and I'm not 100% sure if the version on the Stanford page is still maintained or what is the status. But for sure, this one is actively maintained, and this is the one that I will talk about. I would like also to point out a couple of, let's say, I put them in the form of warning. I don't know if they are real warning, but I think they are, let's say that they are things that is useful to know before starting looking at this tool. And the thing is that the integration is very new. So the first warning is this one below. This is a screenshot from one of these pages. And the maintainer of the library themselves state that the API is quite new, let's say, and so and they are still working on the integration. So it's likely to happen that there will be changes in this API. Okay. And the other thing is that also when I started playing with this, so nothing worked, and I realized that I needed to install a fresh installation of all the packages involved, so PyTorch Geometric and everything. So I really think that it works with the latest version. So it may be my fault. It may be that I had something really out of date on my in my environments, but I think it's a good idea to start with a fresh environment and a fresh installation of PyTorch Geometric to have everything working. But then as soon as you install the latest version, it works without any problem.
Okay. So probably, Gabriele, you're pointing out that the best solution is to create, I don't know, an environment.
Yeah, that's what I did. So I have a new environment. I downloaded the latest version, and then it works without any further modification. Yeah, that's okay. It. Yeah. Okay, so about the goals. So what is this package for? So the idea is to make it easy to design and execute experiment. So there are three main ideas. One is modularization. So you can easily pick components of an experiment, like building blocks on the right. Okay, so you can pick a data set, a model, a task, an evaluation metric, and an optimizer, and you can really describe them at a very high level. So you don't need to write any code at all. So as long as you stay within the design space that is specified by this tool. So there is a design space with some degree of freedom, but it's quite rich and quite nice. And as soon as you stay within these boundaries, you can really pick all these components without writing essentially any line of code. Okay, and we will see how to do that. This is already nice for modularization and to design experiment. And then the tool also makes it easy to have a reproducible experiment, because you can describe an experiment by a configuration file, and then that's it. So every time that you call the experiment, so you use this GraphGym tool using that configuration file, you are 100% sure that the same experiment will be executed. Okay, so this is good if you want to write a paper or something like that. You can publish your version of this configuration, and the experiment is set for it will be that one. And also the tool makes it easy to scale the experiment, because there are a couple of very easy definition to scale the execution to multiple, so to parallelize the execution and to test multiple settings. Okay. So these are the basic idea and how to use these tools. So what is recommended to do is just to clone the repository. So this is a screenshot from the repository of PyTorch geometric. And as you can see, there is a folder GraphGym within it. Okay. And you just need a fresh copy of this folder. You don't need the full repository. You can clone everything and then take out this folder, or do it as you wish. So copy, download it, whatever. And within this folder, the structure is like this. Okay, so you just need this folder, and it contains the entire tool of GraphGym. Okay, and how is this organized? So there are configuration files. They are within the configuration, the configs folder, and the grids folder. I will discuss later what the difference between the two. Then there is there are a bunch of shell scripts here that are examples on how to run. So actually, the last two are examples to run a single node or single experiment of multiple experiment. The first one, parallel, is just used by one of these. And then there is a folder where the results are stored. Okay, so the structure is very simple, and you just need this one in order to run everything, plus an installation of PyTorch geometric. And now in the following, I will go through these two examples down here and see what's happening. Okay. So let's see that. So we start from the first one, and let me share it. So window. So this is my terminal, and as you can see, okay, you should be able to see it now. So I'm within the folder in my local machine, and you see exactly the same files and folder that I showed before. And what I do is just execute the script run single. Okay, and if I launch it, you see now it will be very fast, but we will see that some experiment is running and is showing metrics on the standard output. Okay, so let's let it run, and we go back to the slide and come back to see the result. It will take some time here. Okay. So let's wait for the sharing to run. Okay, so what did we do? So this is the content of the script that we just ran. So this run single point shell. And there are multiple commands, so 3 of them actually. I just commented the last 2, and I'm just running the first one. Okay, and let's see the details of this. So the first part is just running this main, which is the base GraphGym file, and it does parsing of argument and execution of the code itself. Okay, so this is actually, you don't need to modify it. You can just execute it like that. And then it takes two arguments. The first one is a configuration file. You see there is this option to pass a configuration file. And within this configuration file, we are going to see it in a moment, you define everything about the experiment. Okay, so any aspect of the experiment is defined within this configuration file here. And then the second part is just an option to specify the number of repetition of the experiment. And what this option does is to run again the same experiment defined here, but just by changing by running the experiment with a different random seed. Okay, so essentially you can specify a number of repetitions, and then you just repeat the experiment with different random initialization of various things in order to minimize the effect of this randomization. Okay, and we will see how the result is aggregated in the end. But the execution is very simple. Okay, so the only thing that we really need to understand here is how this configuration file is defined, and we see it in detail. So this is the content of this configuration file, the one that we passed there. So this example node, this is provided by the package, and is an example to run a simple node classification task. Okay, and you see it's a simple configuration file. It's just a list of options, and we see them one by one. So just a general thing before, sorry. So the idea is that really you define parameters divided into group, and any parameter that is not specified in this list is given a default value. And to know all the possible parameters that are there, and the explanation of the parameter, and also the definition of the default values, you can have a look at this link. So this is the code for this method set configuration, set CFG. And within this method, you can find the full list of possible parameters and the default values. So once again, you don't need to specify this full list of parameters. There are actually many more, but you need just to define the ones that you need. Okay, and now we really see them one by one. Okay, so there is just one thing that, so I mentioned that the tool is quite young here. So in my opinion, some of these parameter in this example are not 100% clear. So there are a couple of places where some parameter is useless, and it could have just been set to the default. I will tell you where. Okay, so let's start. So the outdir parameter is just, as you can imagine, the place where you want to save the results, so the folder called result. Then there are parameters specifying the dataset option. Okay, and here you can see the first one is the format, and the options are either PyG or network X. So whether you want to use one or the other format for the dataset. That is the name of a valid dataset, the name of a task. So it can be node or edge or graph or link prediction, and every one of these is a different task within the possible dataset. Then task type. In this case, it's classification, and it can be classification, regression, or binary classification. Okay, so once again, these are the option that is specified to run this single experiment, and all the valid options that you can set. Okay, and then this node encoder and node decoder here are both set to false, because these are if you want or not to use an encoder for the node and edge features. Okay, and we set it to false here, and here is the first place where there is some redundancy, because actually at this point you don't need to specify the name of one encoder, because you just said that you don't want to use it. And but I mean, I think within the implementation of the package, this is just they never see these two values, because the code finds the flag set to false before. Okay, but that's it. So here you specify everything about the dataset. Then the training option. So these are about, as you can imagine, the training of the method. So you can specify a batch size, and then evaluation period. So is the number of epochs. So if you like, this is 1, it means that at the end of every epoch, you evaluate the model on the test set and save the result. And the same thing is the checkpoint period. So every 100 epochs, the model is, so a checkpoint is saved. And then the sampler is the strategy to use for the train loader, the sampling strategy for the train loader. Okay, so you see, if you remember, we had some tutorial the last spring on the definition of a lot of options for defining the data loader. Here is super easy. So we know that these things have a meaning within PyTorch geometric, and here you just need to give a name and you will automatically use the corresponding tool that corresponds to this name. Okay. Then about the model, so here the only thing that is implemented so far as type is GNN, which makes sense. And the only thing that you can change is not changed here. So it's set to the default is the type of layer. Okay, but okay, it's a GNN. No, sorry, it is below. And then you define a loss function. At the moment, the implemented one are cross entropy and mean square error. If the task is about encoding, you can specify an edge, so the decoder for the edges. So in this case, we don't use it. So again, this is redundant, but you can decide between dot, cosine similarity, and concatenation. And graph pooling, again, so if the task is about graph prediction instead of node prediction, like here, you can specify the type of aggregation for the graph, for the pooling, okay? And again, this is a complex thing that will require to write a lot of code. Here, you just pick the option that you want. Then about the GNN model, so this is maybe the most interesting thing, and this really dates back to the original paper that originated this tool. So the idea is that the researcher and the author of that paper like studied and recommended like a kind of standardized architecture for graph neural network, and they ended up with this setup. So they defined these three macro layers. So the first one is a pre-processing layer of the features. Then there is the really message passing part, okay, and then the post-processing layers that use again the learn features, okay. And within the message passing layer, every one of the layers is made of is made of this simple part that you can have or not. So a linear layer, a batch normalization, a dropout, a type of activation, and then some form of aggregation. So we have seen this multiple times last year, and really this GraphGym tool works around the assumption that your model can be written in this general form here. Okay, and if this is the case, what you can do on the left is really just specify every part of this in a very simple way. So you can first specify these first three variables that are the numbers of layers in these three macro layers. So the number of message passing layers, so the pre-processing, the number of message passing layers, and the number of post-processing, so after the message passing. And you just need to put a number here, and the code will, so the package will take care of building a model that have this number of layers. And then the second part of the option are really about these inner parts, so the message passing part. And you can specify everything. So the type of layer that you want. So in this case, GCN convolution, and everything really. So the type of stage, the batch normalization, a parametric ReLU activation, if use dropout and with what rate, type of aggregation, and whether or not to normalize the joint, and a lot of other options that you can find in the file that I linked before. Okay, so really here you can design your model, your architecture, just by putting the name of what you want to use here, okay, and the options. And finally, the last set of options is about optimization, and here these one are really straightforward to understand. So I let the check here. I checked this actually. So at the moment you can really just choose between SGD and ARM, and then these are obvious parameters. So the base learning rate and the max number of epochs. Okay, and again, if you specify these, then the code will be trained by using this one as parameters of the optimizer. Okay, so all in all, this is the full configuration file, and you can specify a lot of parameters to define your model, the kind of training, and the kind of optimization and data set that you want to use. And just so at this point, you may, I mean, what I found confusing when I first saw this is that it looks like you can really play with any kind of definition. So what instead of cross entropy, if I want to use something else here? And so I started to look around to see where you can find a full list of options that you can put here. And this is the content of the object of the next slide. So before I said you that you can just look at that file and that I don't go back there. So at that configuration file to see all the options, and that's true. So you can see the list of all available options in the implementation of this method here. But it's also true that the actual, so this is actually a list of things that are available. But the actual implementation of the things, it can be found in the single modules that can be found in the code here. So actually, there is no way at the moment that the package ensures that what is listed in the first thing as a command correspond exactly to what is present in the implementation. Okay, so if you really want to make sure that you have everything, either you believe the developer that they put the correct list in the first method, or you can check it. And so as an example, if you look within the code of this first method set configuration, you can go to the point where the type of losses are specified. So this is the default value that I told you before. And if you look at the comment, it tells you that the ones that are implemented are cross entropy and MSE. And this is what I told you before. And then you can check in the code if this is the case. So if you look at within this code that is linked here, it's really, so this is the file loss within the path. And you can really see that the only options that are accepted are cross entropy and MSE. And if anything else is passed, it raises an error. Okay. And but I don't see any way in which if I add a new method here, this will automatically go in the list of recommended one here. Okay, so as soon as this tool will start growing more, I guess they will find a way to automatically get the list of implemented method out of the code instead of relying on hard-coded comments. And by the way, there is also a way to extend the list of possible usable method, but we will see it at the end. So there is a lookup here in the register to see if there is something else implemented, but we will see this at the end. Okay. Okay, now about the result. So as I said, the results are saved in this result folder, and then a new folder with the name of the configuration name file is created. So in this case, the result will be saved within results and example node. And let's see the structure. So we set the number of repetitions to 3. So within this folder, 3 subfolders will be created, 1 for every repetition. Okay. And within each of these one, you can find folders for train, test, and validation. A login file, which is just that listing that you saw in my terminal before, and then the checkpoints that you define that you want to save during the execution. And within each of these test, training, and validation folders, there is a file containing all the statistics corresponding to the metrics for testing, training, and validation. And then there is the most important part, so this aggregation folder. And this one again contains test, train, and validation. And within every one of these, there are 2 files, one with stats that contains everything as before, and another one that is called best. And this is just the best epoch based on validation accuracy. Okay, so you can really find the entire set of results plus an aggregation over the multiple repetitions of the experiment. So this is a very easy tool to streamline the execution of multiple testing and averaging over multiple initialization. Okay, so let's see this. So I hope the execution finished in the meantime. Let's check that. Yes. So this is again the same terminal as before, where I started the execution, and it finished running everything. And at the end, it tells you that the results are aggregated across all the runs, are saved in this folder. And then what you can do is just to to launch a TensorBoard, with log dir exactly the one that you receive from as an output of the execution. And let's do that. Okay, and now I open it. Okay, let me go to see it. Okay, it's loading. Okay, and here are the results. So it's just everything that you expected. So it's just the test train and validation results. So you can do the usual thing. So this is just to show that the execution of the script makes sure that the results are saved in the correct format to be able to do what you would like to do with a TensorBoard. So you can just see train, test, and validation result. And then this is a plot for the accuracy. Then there is the standard deviation because we had 3 repetitions. So we have also result average over multiple repetition. And you can really explore all the type of things that you usually do with a TensorBoard. Okay, but really this is super easy in the sense that you can just run that script, make sure that you define the configuration in the right way, and you automatically get the result in a format that can be easily parsed by TensorBoard, and you can visualize everything. Okay, and this is all about the execution of a single experiment. So really define a configuration, run the script, and visualize the result. But now this tool can do much more than that, and this actually leads us to the second experiment, the second example. So this batch training, which is the idea of running not just one experiment, but a series of experiments to test multiple options. So the idea is to have a base configuration file like the one that we had before, and then have a set of rules to perturb this base configuration file to obtain new ones. So in more details, we have a configuration file that is exactly the one that we had before on the left, plus a set of rules to perturb that. And these are saved in the second configuration folder that I showed you before, so the grids one. Okay, and the format is very easy. So you can read here that for every row that you put in this, you can put as many options as you want, as you wish, within this grid file, and it's very simple. It's very similar to scikit-learn cross-validation if you want. So for every parameter, so for example, for the GNN layers, the pre-message passing, so the pre-processing layer, before we had 0 layers, and now maybe you want to experiment with different options. So you can just first write the name of the option as is written here. Okay, then define an alias. So in this case, we call the alias, the name that we give to this option is pre, but you can call it whatever. So you can call it Gabriele if you want. And then you just specify the list of values that you want to test. Okay, so in this case, we want to run the same experiment, but see what happens if we use either 1 or 2 pre-processing layers. Okay, and the same is with every one of these other parameters that we specified here. So for example, you want to test this learning rate. So this is one value, so you just change the value from the configuration file to this one. But if you wanted to test multiple ones, you can just add a list. Okay, and what happens is that these lists of parameters define a grid, a search grid of multiple parameters, and the code takes care. So the GraphGym takes care of running all of the possible combination of these parameters. Okay. So and how this is done is very simple. So let's see this run batch. In this case, I don't run it because it takes a long time, because it needs to run all the experiment for all the possible combination that we defined here. But what it does is very simple. So there is a first part in this script where you specify first these 2 files that I show you. So the base configuration of the experiment and the grid file. And then some options. So the repeat is as before. So how many times to repeat a single experiment, and then options about the execution. So the max number of jobs, the sleeping between one and the other, and what is the main file that you want to use, which is exactly the one that we had before in the script. Okay. Then the second part is this one, and what this does, it calls this function configuration generation, and this just creates for every perturbation of the original configuration file, creates a different configuration file. Okay? So you can inspect it at the end. So see what is the configuration that you're actually running. And then this part just run all the possible configuration that you generated, and then there is an aggregation. Okay. But the only thing that you need to modify actually is just to specify this option at the beginning, and then this code is the one provided by the package within the package, and it will run everything for you and aggregate the results. Okay. And let's see these results. So in this case, we run a lot of experiments. So this is the screenshot of the folder that is obtained at the end of the running. So once again, I'm not running it now because it takes quite some time, but I did it yesterday, and in a reasonable time, you get all the results. And what happens is that first you get, for every possible configuration file, you get a single folder, which is representing a single experiment, which is exactly what we have seen before for a single experiment. The only difference is that here the name of the folder is given by the parameter used, and the parameter are abbreviated by the name that we gave. So before I told you that L pre, you can call it Gabriele. If you call it Gabriele, you will find it here in the name of the folder. Okay. So if you want to inspect the result of every single experiment, we'll just need to open this folder and do exactly what we did before. But now you also have an aggregation over all the possible parameters that you tested. And within that folder, there are test, training, and validation folder files. And for every one of these, there is, so you can see the accuracy at the final epoch. So the test without any other name is a final epoch. Then the one that's called best are the result for the epoch with the highest average validation accuracy, and the one with best epoch appended are the one for the epoch with the highest validation accuracy and also average over the different random seeds. Okay, so for every one of the test, train, and validation set, you can inspect the results. So these are really table. You can check all the different combination of the parameters that you checked, and for every one of those, it tells you the best performance, the final performance, and the best average performance. Okay, so you can really just look at the final table and pick your best parameters from your configuration, and you automatically tested a lot of different configuration, a lot of different optimization, training, and whatever, and you can just inspect this result at the end and pick your best configuration. Okay, and this is all about the second experiment. So I don't show you the table because it's just a list of configuration, so of values of the configuration options, parameters, and accuracies. What I would like to tell you is two small warning. The first one is that there is a small bug in the script, the run batch, because this one does not create this finite folder. Okay, so actually, if you change the name of if you go back here and you change the name of the configuration file, you need to make sure that you also manually create a folder that is named in the way that this script expects. But I think this is a minor mistake, and also I think we will do a pull request for this small feature. So there is just a make dir missing in the first line. But otherwise, you can just name your configuration file example node and example, and you will be fine. Or manually create the over folder for this one. Okay. And the second minor warning is that within the script there is also an option here. I don't know if you can see it. Is this configuration budget here, which is commented. And the idea of this is really nice in my opinion, because you can additionally specify a base configuration file, and that is used as a reference for the budget, for budget constraints. So all the configuration and the architecture that you test are a reference to that one, and there are constraints. So automatically added to the models in order to make sure that you use the same number of parameters as this basic architecture. So this is the idea, and I tested that, but it's not well documented yet, at least not as sufficiently well so that I can understand how to do that. And if you just uncomment that line, you get a bunch of errors. So I guess they are still working on that, but the idea is very clear. It's also very nice to be able to not only compare different models, but compare different models like by normalizing them from the point of view of the number of parameters. But I still didn't figure out how to do that. So I will just take note of this, and in the future tutorials, so if we figure out how to do that, or if they modify the interface, I will just take 5 minutes and tell you how to do this. Okay. Okay, and then final slide about configuration. So you have seen that at the moment, for example, for the loss, there was only 2 options implemented. And while within the PyTorch geometric, there are a lot of them. And it's the same for architectures and everything. So there is also an official way to customize this tool. And you can add new, so register new everything, modules, losses, options, whatever. And you can do it either for, let's say, personal use, so you can have your local folder, as I have, as I showed you from my computer, and you can register your. So let's say that you develop a new layer, and you want to publish a GraphGym implementation together with your paper, for example. You can just do it locally and then publish this folder somewhere. Okay. But also you can contribute to the general PyTorch geometric. And actually, in this case, you can add your new implementation within this folder that I added here. And then just do a pull request and they will add it. And actually, at the moment, the one that are implemented, so within this folder, you can find some folders for all the types of, all these type of options. So activation, configuration, feature augmentation, whatever. Okay, and the idea is that you can pick something that is implemented within PyTorch geometric and realize this registration in the register of GraphGym, or also implement your own one. So for example, if you check within the loss functions, so sorry, what I forgot to say is that within every one of these folders, this is an example on how to register a new one. So for example, if you look at the example within the loss function, it looks like that. So you can define a new example that you call loss example, and you just register the smooth L1 loss. Okay, so this is existing within PyTorch. Okay, so you are just importing it, but they show you how to register this one as a loss that is available as an option from GraphGym. Okay, so after you do this, within GraphGym, you can specify smooth L1, and this will be one valid option to put in your configuration file. So I think this is really a nice way to contribute to the project, because it's just taking things that are already implemented within Torch or PyTorch, so within PyTorch or PyTorch geometric, and you can just provide registration within this registry, and then register, and then it will work for everyone within this very, very nice and high-level interface. Okay, and yeah, also it's possible to define new fields of configuration. So this is modifying the losses that is already existing. This is adding, you can also add a new one, but I will not talk about this here. So, okay, that's it. And thank you for your time. And do you have any question? I'm happy to try to answer at least.
So, sorry, Gabriele, from what I understand, with GraphGym, we can test known architecture, and we can define our custom architecture in some way and test on predefined dataset, or we can also load our custom dataset into GraphGym.
I think if you want to load your one, you can just so you can if you either you can want to do it for personal use, or let's say that you want to do it locally, you can just look within this page. There is a data loader, and they show you how to load a new data loader. So you can do something like this for the loss, and this will just you just define the steps to do in order to register. So let's say that you want to register your own dataset. You call it my dataset, and you provide a registration like this within GraphGym, and then this dataset will be available to you from the interface before. So, which means that you can go back to the configuration file, and well, where it was written Cora, you can write my dataset, and then you will load your dataset from there. Okay, so it's just a high-level interface, but you need to make sure that the low-level thing is implemented. So yeah.
Yeah. Okay. Thank you.
Okay.
Wow, I think it's really an amazing project, and I think it's gonna simplify the life of a researcher in terms of trying different models and compare results. I think it's gonna be really helpful, at least for me.
Yeah. I think as soon as a lot of options will be registered within this possibility, you can really do a lot of experiment without writing a line of code. So it's good at least to, as long as you stay within this. Yeah.
I mean, I totally agree with you. It will be really easy to, even for people that are not coding dependent like us, to do, I mean, learn how to configure this model, this PyGym, and run it on personal data set. It's really an amazing work. Yeah. Are there other questions, guys? Okay. So I think we can see next week on Friday. And as I told you, Francesco is gonna present, so keep in touch.
Yes. So
I hope to see you on 12th, guys.
See you. Thank you all. Bye bye.
Thank you. Bye bye, guys.
Thank you.
Bye.
Thanks. Bye.
Thank you.
Thanks. Bye bye.